So we're going to be starting a new unit today. It's going to be the section 6. We're going to be covering 6.1, 6.2, 6.3, 6.4, 6.5, and 6.7. It's all about factoring and the different types of factoring. So on the test or any question, it's not going to say just factor using only this one method. For every single problem that says factor completely, you're going to check each of these different steps that we have up on the board here. So your first step to factoring any polynomial is to see if we can take out a GCF. The second step would be to see how many terms you have left over, because that tells you what type of method that we're going to use. And then our third step is just to make sure that it's factored completely. So the type of method that we're going to start off with first is 6.1. 6.1, we have to talk about how to factor out a GCF, and then eventually we'll have to talk about how to do when we have 4 terms. We call that the grouping method. We're going to come back to this in a second. So let's start off with what does factoring have to do, or what does factoring mean? So for example, if we have a number, let's say 50. Factoring just means that you're trying to figure out all the items that multiply that will make 50. For most of us, we do a tree diagram. We would say, okay, I know 50 is 2 times 25, and then 25 is 5 times 5. So the factors that make up 50 that are prime is 2 times 5 times 5. Factoring is just basically taking something that was very big and breaking it out into simple building blocks that can be multiplied to get the original answer. When we're multiplying polynomials, we know what polynomials are. If you recall from the last unit, they are items that are separated by addition and subtraction sign. So if you had x squared plus 3x minus 4, I can tell you that we can break this down to be x plus 4, x minus 1. If you multiply these two factors, and that's what you were learning in the last unit, that when we had two binomials that we can multiply it, that when we multiply these two together, we talked about this as the rectangle method. We have a binomial times a binomial. We'll get our x squared, our positive 4x, our negative 1x, and our negative 4. These terms are like, remember, single x, Start with your highest degree, and then this would become plus 3x, and this is minus 4. So what we were doing is taking two binomials and getting this. Well, in this unit, what I'm going to do is give you the answer, and you're going to have to think of what two parentheses or what two factors that multiply to get that item. Now, the first thing that we got to learn is that every single problem that you're going to do factoring, your first step, no matter what, if it has 4 terms, 3 terms, 2 terms, you're always going to look for a GCF. GCF is greatest common factor. Okay, so if you ever hear me say GCF, just remember, greatest common factor. Now GCF can come in 4 different methods or different formats. We have them listed over here. When it comes to factoring out a GCF, these are the 4 different types that you're going to see. The first type is a common polynomial. This is the easiest one to find because all you're going to do is look for matching parentheses. The second type of GCF is when you have a common variable. That means every single term has the same letter, then you know you have a GCF for a variable. For a common number factor, we have to do tree diagrams, and we're going to tree diagram any type of constants or coefficients. And then the fourth type is if your polynomial starts with a negative, then that negative must be part of the GCF. So these are the 4 pieces that we have to worry about with a GCF. Some of them will have maybe 2 or 3 of them. Some of them might just be one of them. But we're going to check every single problem to see if there's a GCF. And we're going to be going through A, B, C, D. Let's start with the A and give you some examples of what A would look like. So here is technically a binomial. You might be saying, well, wait, I see lots of pluses and minuses. Well, this plus separates this from this. This minus, because it's part of the parentheses, this is still considered one term, everything from the parentheses and what's multiplied. Looking at the two terms, to see if there's a GCF, your first step is to see if you have any matching parentheses. Notice that we have a binomial 3b minus 2 and another binomial 3b minus 2. Clearly, we have a GCF. Each term has matching set of parentheses of 3b minus 2. Once we find out our GCF, we're going to have to rearrange our answer so that we have a GCF in front, and then our leftovers will be in the set of parentheses. Since we know our GCF is 3b minus 2, the matching set of parentheses, we can put that here. Even though we have two of the parentheses, you're just going to put it as one item, the GCF. To get the leftovers, what you're going to do is take each term that we have in the polynomial and divide it by the GCF. So if I put a 3b minus 2, divide it for this term, and also divide it by this term. What I mean by division, we can just use a fraction bar. And then you can see if you reduce a fraction, remember if you have any factor on top and the same factor at the bottom, like here, matching parentheses, they can cancel out. We can do the same thing in this parentheses. Notice 3b minus 2 on top, 3b minus 2 at the bottom. Notice our leftovers. We have a 5a that did not get canceled out, and then in this term, a positive 7. This is what I mean by leftovers. The stuff that did not get canceled out, you're going to put this as a set of parentheses. So the 5a, and notice this is a positive 7. Whatever sign this is, bring it down. Don't put it as a plain 7. If it has a positive sign, bring it over. Because if you look at this, this is a binomial times a binomial. If you multiply these two guys out, you would get the original problem here.